Assalamualaikum warahmatullahi wabarakatuh. My name is Nuviya and Aturroifah. I'm from State University of Malang. In here, I will to present about my research. The title is Effect of Electrolyte Type on Supercapbattery based on silicon as Anoda and Cassava tuber activated carbon as Cathode. Introduction. Battery and supercapacitor are examples of energy storage devices that are widely used. Battery and supercapacitor have advantages and disadvantages. Advantages of battery is high energy density and disadvantages is low power density. Supercapacitor have advantages are high power density and long cycle life, and disadvantages is low energy density. Supercabattery combining this component of porous supercapacitor material and battery material overcome the respectively weakness of battery and supercapacitor to improve electrochemical performance. This is the component of supercabattery, and electrolyte believed to be a component other than electrode that play a role in donating the ideal performance of a supercabattery cell. Two types of electrolyte are often used: organic and aqueous. In the some previous research, we get cassava have the highest electrochemical performance with a specific capacitance 300 farad per gram in 5,000 cycle and with a 6 molar potassium hydroxide electrolyte. In this research, the manufacture of supercabattery is composed of activated carbon from cassava tuber as cathode and silicon as the anode to improve electrochemical performance. The use of silicon for the anode of supercabattery is because silicon has a long operating voltage, environmentally friendly, and widely available in nature. And then for method, synthesis of cassava tuber activated carbon, first with grinding and drying, and then pre-carbonation and activation with 3 molar potassium hydroxide and stirred 47 24 100 24 hours, and then oven carbonation with a furnace with 600 degrees Celsius, and then sample ready to characterization. And for fabrication cassava activated carbon, we use NMP for the solvent, and we mix PVDF and NMP in 60 degrees Celsius for 1 hour. And then for fabrication silicon electrode, we use the emassive for the solvent, and the ratio used for active carbon, burn black, and binder we use 811. And then for fabrication coin cell supercapacitor, we shocking the electrode in variation electrolyte. In here we use 6 molar potassium hydroxide and 1 molar 84 NH4 for 24 hours. And this is how to arrange coin cell. For result and discussion, XRD analyzed. This is a graph of diffraction pattern from activated carbon commercial and activated carbon cassava with activation 3 molar potassium hydroxide and 2 diffraction peak from indicated amorphous base. And the diffraction pattern, we get good effective electrode material. That because a KOH activation active factor the intensity of the peak. The peak intensity influenced from the cellulose content that form a hexagonal structure. And this is the graph of a diffraction pattern silicon powder according to the standard silicon GGBTS. And from every bit, we use highest intensity. We get highest intensity in 2 theta to 28.4 degree. And the size of the silicon powder is nanoparticle. The formation of chemical bond on nanoparticle is such a way to accelerate the transfer of electron in electrochemical process. And Sam analyzed this is the image from activated carbon to a cassava tuber, and we get a particle size distribution 8.87 micrometer, average per diameter is 0.988 micrometer, and porosity percentage 69.49%. KOH activation can remove impurity on the carbon surface and increase the pore size, the transmission of ion, and are an effective reservoir for the electrolyte. Percentage of porosity is the number of pore affect the amount of chain storage. And this is the image from silicon powder, and the space is spherical. The particle size distribution of silicon powder is 0.065 micrometer. The smaller particle size is used to avoid cracking and crumbling when applied as an electrode to avoid the trace of capacitance. And this is the FTR analyzed. The FTR absorption peak produced by activated carbon commercial is smaller than activated carbon cassava tuber. This is influenced by the activation temperature. And this is the electrochemical performance. We get a graph time versus voltage from charge discharge galvanometer test. In here we get the stationary peak, and this condition is indicated by the presence of solvent. The composition cell voltage caused by the type of electrolyte used. The use of 6 molar potassium hydroxide electrolyte results in better electrochemical performance when compared to 1 molar ET4 and BF4 electrolyte. Better electrochemical performance when using a 6 molar potassium hydroxide electrolyte is in symmetric supercapacitor. 6 molar potassium hydroxide electrolyte is a aqueous electrolyte that uses water and a solvent to allow for the discovery of a salt, which organic electrolyte cannot produce. Using 6 molar KOH electrolyte was increased in supercapacitor based on cassava tuber activated carbon as cathode and silicon as an anoda. Conclusion: cassava tuber activated carbon has been successfully synthesized using the chemical activation. Silicon electrode has also been successfully application in as negative electron for supercapacitor. Except this diffraction pattern of cassava tuber activated carbon has almost the same of chemical activated carbon, and silicon powder had a crystalline structure. The absorption pattern of a test result on activated carbon has more amount than chemical activated carbon. And the full surface morphology of cassava tuber activated carbon has a porous structure. At the same time, the particle size distribution of silicon is 0.065 micrometer. Electrochemical performance testing used two types of electrolyte. One our 84 MbF4 and 6 molar potassium hydroxide electrolyte. The 6 molar potassium hydroxide electrolyte provide better electrochemical performance than the 1 molar 84 NPF4 electrolyte. I think enough. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.